Hello everyone. Welcome to this training session on statistical analysis using Excel. As a part of this session, we would be dealing with a continuation of the descriptive statistics which we have done in our last session. In the last session, we had focused primarily on the two key aspects of data, which are the central tendency as well as the dispersion. And we have discussed on the various tools that are typically available to measure the central tendency of the data as well as the dispersion that is present in the data. And we also discussed that apart from the central tendency and the dispersion, we need to look at two more aspects of the data, which are the third and the fourth dimensions of it, and which are measured through tools like skewness and kurtosis. Right? If we go back to our data, right, just as a quick summary, we have already computed the measures of central tendency for the cholesterol as well as IQ levels, and we have also talked about the standard deviation, the variance, which are the measures of dispersion. Now, to understand the skewness in the data, the skewness actually talks about whether the dispersion which I have, let's say in case of cholesterol, we were talking about that the deviation is around 21.96 units. Now, what the skewness tells me is the deviation more or less uniform towards the left and towards the right of the mean, or is it more towards the right of the mean, or is it more towards the left of the mean? That is what is typically being explained by skewness. So, is the pattern of dispersion more and more uniform towards the left and the right of the mean is what is the key aspect of skewness. And in Excel, we have a formula called skew. So, what is that I can measure through skewness? Let me just compute the skewness on the cholesterol data. Okay, skew, and I apply this on the G column out here. So this gives me that the skewness is 0.77 for cholesterol, whereas I will compute it for the IQ levels. I get that the skewness is 0.23. What does it indicate to us? A 0.77 is actually a positive value. If at all any data has no skewness or is symmetric, we see that this coefficient of skewness value, which is given by the skew formula in Excel, it will have a value equal to 0. But if that value is a positive, like 0.77 in our current example, we call it as positively skewed data. Otherwise, we call it as negatively skewed. Right? Anything which is positive in terms of coefficient of skewness, we call it positively skewed. Otherwise, we call it as negatively skewed. And getting an exact 0 is a very difficult thing, especially when we are working with data. Right? We may get more than 0 or we may get less than 0. So, it doesn't mean that every time I will say whether it is a positive skewed or negative. Sometimes we even give some level of small interval to it. We say as long as the value is within a plus or minus 0.5 zone, probably point plus 0.2 minus 0.2, just like the way we got in case of IQ levels. If it is within the range of minus 0.5 to plus 0.5, we can still assume that there is a symmetricity in the data. Though there is a slight bias towards the positive, we can still talk about a symmetricity present. Which means skewness, if it is as good as 0, as close to possible to 0 as possible, we can clearly say that the distribution of the data, the pattern of the data is more and more symmetric. Otherwise, we will associate asymmetry to it and we will say that there is a positive skewness. What do I mean by positive skewness? In that case, a couple of more things to check out. If there is a positive skewness, I can also see it in my mean being higher compared to the median. If the mean is more compared to the median, we can very well say that the skewness will be positive, whereas if the mean is lesser than the median, I can associate that the skewness will be negative. So even from that standpoint, just with the comparison of the mean and the median, we could have said that the skewness is positive. Even while calculating also, we get the same kind of a result. And skewness is positive means there is a possibility of some extreme outliers on the higher side. There are a couple of positive values on the higher side that are taking the mean above the median. If the data doesn't have too many outliers or extreme values, we will see that the mean, whatever is the measure which we are using for calculating the central tendency in the data, whether it is a mean or even the median, we will see that both of them will give more or less the same value. But in this case, the mean is giving more value compared to the median, which is an indicator that the skewness is positive in this aspect. Right? So there are some extreme outliers that are present in the data. In case of IQ levels, if you see the mean and the median, there is not too much of a difference. 110.5 to 109.5. So because there is not too much of a difference between a mean and a median, even we are able to see that the skewness is also not that heavily positive. Because on one side we are seeing that there is a small difference between the mean and the median, because of which the skewness is still expected to be positive, but it is not so high, that it can be considered as a significant positive difference. So we can very well go about with the symmetricity in the data if we have this much of very small values of skewness. But if that kind of value, even see, it should be actually 0. But we are still giving some level of leverage around 0. But anything more of a leverage is not a possibility. So if at the moment it crosses 0.5, we will typically consider it as to be skewed itself. The same way goes on the negative side. Less than minus 0.5, we will take it directly as a negatively skewed kind of a data. So this is one pattern we would be analyzing, and the skewness directly talks about few things. In case of positive skewness, I will observe that there are some extreme values on the higher side. If the skewness is negative, I can take that there are some extreme values on the negative side. And because of the presence of those extreme values, my other calculations and in the future predictions and estimations, they go into a problem. That is where we use some other mechanisms to identify the outliers and eliminate the outliers. But at the face of the data, just by looking at the skewness, I can talk about whether there are any extreme values present in the data. Alright? Okay. Then the fourth dimension that is being typically looked at in the data is the kurtosis. Kurtosis is measure of the peakedness, especially it talks about the distribution in the tails, in the extremes, as well as the distribution in the middle. How is the distribution of the data in the extremes? Do I have too many outliers in the extreme versus the concentration of the data in the middle? Again, the same logic. I should not have too much of a concentration in the outliers and also too much of concentration in the middle. The data should be as much normal as possible. So that from that standpoint, we are using the kurtosis as a mechanism. In a tool like Excel, the kurtosis actually can be calculated through a formula called KURT. Let's try to apply this KURT on both the cholesterol data as well as the IQ levels data. When it comes to cholesterol data, it is around 0.43, and on the IQ levels also, if I am applying this KURT, it is coming out to around minus 0.78. Now, again similar kind of analysis can be made. Probably I will compare it again for a data which is more and more normal in nature, which doesn't have too much of concentration or too less of concentration in the tails, will have a kurtosis value very much closer to 0. Right, from a statistician or a technology, from a statistician standpoint, or technically, this kurtosis is also called as excess kurtosis. Whatever the Excel computes as the kurtosis is called excess kurtosis from a terminology standpoint. But yes, the interpretation standpoint is for a data which doesn't have too much of concentration in the tails or too less of a concentration in the tails, is what we call as a normal data. Not too much of concentration in the tails, as well as not too less of concentration in the tails. We associate that kind of a data as a normal data. And in case of normal data, we typically see, in case of normal data, we typically see that the kurtosis levels will be closer to 0. Again, if it is too high, if the kurtosis is too high positive, what we see is more concentration of the data is there in the tails, whereas if I see it as too much of negative, I will talk about too little concentration in the tails. So again, from that standpoint, because the data is not normal in either of the cases, we may have to do some kind of transformations on the data to associate the normality to the data. So if I look at the cholesterol kind of a data, I am seeing that the kurtosis levels are positive but not too high, they are not even 0.5. So I can very well associate it to almost normal, almost not too high or too low concentration in the tails. But whereas in case of IQ levels data, I am seeing that the kurtosis is negative. Because of this negative value, I can very well conclude that the kurtosis being negative is an indication that there is a too little concentration in the tails, but which is lesser than the normal. So if I summarize now, once I understand the four dimensions of analysis of data, if I have to summarize from a skewness standpoint, for cholesterol data, I can summarize some of the things. The mean is greater than the median, which is also being supported by the skewness being very much positive. And also I am seeing that the distance between the third quartile and the median is much more than the median and the first quartile, which is also an indicator of the skewness being present in the data. The coefficient of variance is around 10.22%, which means on an average, all my values, each of the value is deviating by around 10.22% from the mean. Kurtosis is not that high, which is an indicator that not too many outliers are also there in comparison with the data. But again, 0.43 is also not very close to 0. So probably there could be one odd outlier present in the data here and there. The same logic, if I am looking at the IQ levels, the mean and the median, not too much of a difference. Very small difference. That's the reason even your skewness is very slightly positive. So even in the extreme outliers case, there are very few outliers there could be hardly one or two extreme values that could be present in the data. How do you identify your outliers and all? I'll come to that. Right, but initially our focus is look at these 4 different aspects of your data and do some kind of quick analysis on the patterns of the data. Now, one is you can use these kind of formulas, and 2, in a tool like Excel, you have another way where you can get all these calculations done at one single location. All these calculations done at one single location in one single shot through a mechanism called descriptive statistics. Let's see how we get that. Descriptive statistics. In Excel, get into the data tab. Under this data tab, just check out if you have this analysis section here and you have the data analysis as an item there. If you have the data analysis, well and fine, we can start using it. But if you don't have data analysis, the simple way is it is present in your Excel but not shown by default. It is present as a part of your add-ins. We may have to understand that it is present as a part of the add-in. So what you can do is you can go into the Excel options from the Excel menu, go into Excel options, get into the add-ins, and your add-ins will get displayed. Once you have your add-in Microsoft Excel add-ins, you can say go, and here you make sure that your analysis tool pack and analysis tool pack VBA are selected. Only when they are there as a part of your installation, you will see the data analysis icon here. So once you do that and say OK, a small implementation will go on your system, which will give you the data analysis pack here. So now that you have installed your data analysis tool pack on your system, for getting the descriptive statistics, all I can do is I can go into the data analysis. This is actually a section where almost all your statistics part of Excel is taken care of. Whatever Excel can do as a part of the statistical analysis, that entire thing is present in under this data analysis add-in. So descriptive statistics is something which will compute the mean, median, the measures of central tendency, measures of dispersion, skewness and kurtosis present in the data. So I go to this descriptive statistics and it asks me for the input range. So I will typically select the input range being the entire cholesterol data, right? And because the label is present in my first row, I will select that. And the output range probably I will select, and I will present it, let's say here. This is where I want my output to be displayed, and all I can ask for is get the summary statistic, right, which is the same as the calculations that we have done till now. The measures of central tendency, dispersion, skewness and kurtosis. They are all given in one single shot as a part of the summary statistics. So we don't need to use the explicit separate formulas for each one of them, but the interpretation part is still the same. So if I say okay here, okay, the input range, here it is, I should select it from here to here, okay. Input range must be a contiguous reference. Okay, it's typically not taking from another sheet. Alright, so let's do one thing here. We'll go into this data sheet. These are some of the problems with the automated version. I go into the data analysis, descriptive statistics, right. I will now choose this entire column, the cholesterol column. In the output range, I'll put it in a new sheet, right. I put this output range in a new sheet, in a range which is the analysis sheet, and I will select this location, which means for input range it does not take from a different sheet, whereas for the output I can try putting it into a different sheet altogether. So output range is a valid reference, okay. So or probably a simple thing is our output range, you take it as a part of the new worksheet. That will simplify the process for you. You take the output range as a new worksheet. The input range, let it be your data sheet. The data sheet, instead of the entire G column, you specify from here to here. And now you can go for a new sheet which will display your descriptive statistics for the cholesterol. So you see that the mean is same as what we have computed, the median is same, the mode, the standard deviation, variance, kurtosis, skewness, almost all the numbers. Even we have done the range, which is the maximum minus the minimum. All these values are typically computed and presented in one single go. So probably all I may have to do is I copy this entire, or I cut this entire thing and paste it as a part of my analysis pack here itself. Now the problem with this mechanism, though it is giving us in one single snapshot the descriptive statistics, the problem with this mechanism for me is if my data changes a little bit. Let's assume that I have added one extra record to my data. This statistics have to be rerun. All these calculations will not be updated automatically. I have to typically rerun this entire descriptive statistics again and again, and probably copy the thing from wherever it got displayed. I copy it back into my analysis location. Whereas if I am using this formulas kind of a model, which we have used slightly earlier in our earlier session as well as early part of this session, in these kind of things, the values are automatically updated, whether it is skewness, kurtosis, mean, median, whatever are the calculations which we want to do, they are all automatically updated. So the formula wise, we'll take some extra pain in writing it in the beginning, but as we realize it, we may save a lot of time as the data keeps changing. Whereas when I am using this kind of data analysis tool pack, it is easy to use. All these values are displayed in one single go, but the disadvantage is every time I run, a new copy of it is typically being prepared, and if I forget running it, my descriptive statistics will still contain the older data. This is the biggest problem for using the data analysis tool pack of Excel. But to make the computation simple, or one time if I want to analyze the characteristics of the data, we can very well resort to the usage of descriptive statistics. And if we really see all the values, whatever we have got through the usage of our formulas, we got similar kind of things here for kurtosis, for skewness, for standard deviation, variance, almost all these things. We got similar kind of values using our formulas also, right? So this is one more thing that we have to be comfortable with when we are solving, when we are statistically analyzing the data. Whatever is the mechanism, either I write my own formulas or depend on the data analysis descriptive statistics feature of Excel. Whatever I am resorting to, I need to be comfortable with the analysis part. The moment I see the mean, median and the mode, the moment I see the standard deviation and the variance, and probably the skewness and the kurtosis, what kind of conclusions or what kind of interpretation I can do on the data. That is the most important aspect for us, because this knowledge is what will go further in terms of making some kind of hypothesis and testing for the hypothesis on the data, preparing the intervals for the population based on the sample, and the whole world of statistical inferences, which we would be doing in our later chapters, all would be dependent on this primary calculation of descriptive statistics itself. And if we see, apart from just displaying the statistics, we can also resort to just finding out the kth largest and kth smallest kind of elements. Even these kind of things can be done, but otherwise there is nothing more than that. So we can very well use the formulas. If you are comfortable with respect to the usage of Excel formulas, we can very well use the formulas itself, like the mean, median, all these most common Excel formulas, rather than the descriptive statistics, because the moment the data gets updated, even these statistic values are also updated accordingly. Probably if I am adding 5 more people, immediately my kurtosis and skewness and all will be updated automatically if I am using the formulas, but not when I am using the descriptive statistics feature. Alright. So probably combining the previous session and this session, it gives you that comfort level in terms of analyzing the data from the 4 dimensions. I hope you are comfortable with doing these kind of calculations and interpreting the data, interpreting the pattern in the data using these 4 computations. If you have any further queries regarding this, you can feel free to call me on the number which I have specified below here, 9848012123, or you can drop in an email to me at vamsidhar@pacegurus.com explaining your doubts. I can get back to them with a detailed explanation to you. Thanks a lot for listening to this session. Thank you very much.